Hey there, welcome to Math 6, Unit 3, Lesson 5, comparing speeds and prices. So we're going to be comparing some speeds and some prices today. And you begin off first of all with looking at the value of each expression, deciding if it's closer to a half, or 1, or 1.5. Just a little activity here. As you think about these things here, a value is going to be close to 1 if the two values you are using as quotients are very close to each other. So for example, if I did 7 divided by 8, those two numbers by themselves are very near one another on a number line, so I'm probably going to get a value pretty close to 1, right? If I end up with a value that the first one is greater than, so an 8 divided by 3, for example, if I'm dividing by a smaller number, then I end up with a number greater than 1, and if I end up doing the other way, a small number divided by a bigger number, I may end up closer to half, especially if these numbers are about halfway apart from each other. So knowing that, when I take a look at 20 divided by 18, I'd say those two numbers are fairly close to each other, and so because they're fairly close to one another, I'd say it's probably closer to about 1. In this case here, I have a small number divided by a larger number, and it's about half the size of it, so I would say we're probably closer to about a half. And over here, we have a larger number divided by a small number, so it's going to be, this is one where you might say 1.5, or you might say 1. It's still pretty close to that, but it's some one of those. So it's up to you. You could do 1 or 1.5 for that one there. It might have been a better problem if that had been 7 divided by 4. You might be more likely to say 1.5, but that's okay. Let's look at the lesson today, comparing speeds and prices. So some students did treadmill workouts, each one running at a constant speed. Answer the questions about their workouts and explain your reasoning. So here we have Tyler going 4,200 meters in 30 minutes. We have Kieran going 6,300 meters in half of an hour, which is also 30 minutes. And May going 6.3 kilometers in 45 minutes. Okay, so let's take a look at what we have here. If I look at Tyler, I know that he's going 4,200 meters, and he does that in 30 minutes, okay, which is great. Okay, if I wanted to figure out how much that was in an hour, I could then multiply both of these by 2 to help me know that in an hour, in 60 minutes, right, in 60 minutes he's going 8,400, right, if I was going to be comparing hours here. If I wanted to find out how much it was maybe per minute, you know, how much in 1 minute, I could do 4,200 divided by 30 and end up with about 140. So a couple things I can look at. Depends on what you want to do. If I wanted to find out by hour and compare it by hour, I could do that. Probably not necessary. If I wanted to compare it by a minute, because this is 140 meters in 1 minute, that might be a helpful comparison. So let's come over here and let's take a look at Kieran. So Kieran ran, in this case here, 6,300 meters in 30 minutes. So again, if we want to find out how much that was in 1 minute, to do a comparison there, we could do 6,300 times 1/30, and we'd end up with 210. So for Kieran, they're going 210 meters in 1 minute. Tyler's going 140 meters in 1 minute. And then finally for May, our last person here, they're going 6.3 kilometers in 45 minutes. So those numbers are very different here. So let's turn kilometers into meters first of all. So I know that in 6 kilometers is the same as 6,000 meters. And because it's 6.3, we're basically multiplying this, and we're going to end up with 6,300 meters in 45 minutes. And so we can then turn that into a 1 minute deal, right? And so that means I'm multiplying by what? 1 over 45. And 6,300 divided by 45, or times 1 over 45, is 140 meters in a minute. Okay, so we've done a lot of work here and we haven't looked at the problem yet, right? What did we do? We've figured out here how fast each one is traveling at constant speed in terms of being in the same units. How many meters per minute, meters per minute, meters per minute. So we did a lot of work there to convert those things. It hasn't asked me to do that yet, but that's just, you know, something I'm going to do right now. All right, so let's take a look at number one. What is the same about the workouts done by Tyler and Kieran? When we look at the workouts done by them, what we know is the same is we know that they both ran for 30 minutes. So the time is the same for both of them, right? That's the same. Okay, the difference would be that one is running at a faster pace than the other one. So we would say here in this case here that Kieran ran faster. The reason we say faster, she did 210 meters in a minute, whereas this one did 140 meters in a minute, which doesn't really make a lot of sense, but that's okay. That's pretty far to go in a minute, but okay. Oh, I guess it's not too bad. I guess a minute. Never mind. I'm thinking seconds. Sorry. All right, but how about Kieran and May? Look at Kieran and May. We can see that for them, they each they ran different times, so the times are different. But overall, though, they ran the same distance: 6,300 meters, 6,300 meters. So the distance was the same here, right? So time the same. This one's distance the same. But again, Kieran started going faster. All right, when we look at May and Tyler, we can see they have the same rate. Their same rate's the same, 140 meters per minute, 140 per minute. But May ran longer. Not faster, just longer, more time. So that's what we can notice there. At what rate did each of them run at? Well, we found that Tyler ran at a rate of 140 meters per minute. We know that Kieran ran at a rate of 210 meters per minute, and we know that May ran at a rate also of 140 meters per minute. Okay, how far did May run in her first 30 minutes on the treadmill? So I know they told you how far she went in 45 minutes, but because we know how much she does per minute, we can take the per minute rate and we can multiply it by 30 minutes to tell us here that she ran 4,200 meters in 30 minutes, right? We just took the 30 and dropped it from there. We took the rate and started with that one. We found out how far she ran in 30 minutes. Okay, that's the idea for that one. Let's take a look at the next activity. Today we're going to skip, are you ready for more? Just skipping over that, and let's take a look at the best deal on beans. Oh boy. Alright, so 4 different stores posted ads about special sales on 15-ounce cans of baked beans. Alright, so 15-ounce cans. And this is something that you would find in the real world quite regularly. Okay, you can kind of look at advertisements or go to different grocery stores and you'll see things on sale for different prices. And sometimes the sale price is based upon the quantity that you're buying. The more you buy, the more you supposedly save. So let's take a look and see what's actually happening here, because the question is which store is offering the best deal. The best deal is going to be probably going to be the cheapest. When you're looking for a deal, you want to spend the least amount of money. So in this case here, for baked beans, we can have a price basically for the number of cans. And that's what we're going to come down to. What's the cheapest price for 1 can? In the first picture, we have 8 cans for $6. So I'm going to put 6 here in the dollar column. I'm going to put 8 cans right there. My goal, of course, is to compare it with 1 can. So to do that, I'm multiplying by what? By 1/8. So if I do $6 times 1/8, and you can use a calculator there, you might be able to figure out what that might be, right? And in this case here, 6 divided by 8 is going to be 0.75. So we know it's going to cost 75 cents for 1 can in that example. Over here we have our dollars and we have our cans, and we know that it's $10 for 10 cans. So that's going to be, to go to a 1, we're multiplying by 1/10. So that's going to be $1 per can. $1 per can. So that's already more expensive than the 75 cents. Over here we have our dollars and we have our cans, and we're spending $3 for 2 cans. So to go to 1 can, we're dividing it by 2, multiplying by a half. So half of $3 is $1.50. Right, that's pretty expensive so far. That's the worst deal so far. I have 75 cents, $1, $1.50. And over here, this one is already given to you in a form. It's going to be 80 cents for 1 can. So that's how much it costs for each of these. We have 75 cents a can here, $1 a can, $1.50, and 80 cents. So the best deal in this case here is going to be this one. The first store has the best deal, and the best deal is 75 cents per can. That's the best deal. Or the 8 for $6, because you can't buy one, they're going to make you buy all 8. Alright, so that's the way that works there. So 4 different signs, and you have to figure out which one's going to be the best deal. You may not think that's the best one, but when you do the math, you find out that it actually is. Alright, so at the end of the day, though, you're going to have a lot of baked beans, so think about that too. Do you really want 8 cans? I don't know. Maybe you're having a party. Who knows? The last store listed is also selling a 28-ounce cans of baked beans for $1.40 each. Okay, so this store here is selling 28-ounce cans for $1.40. How does that price compare? Okay, so how do we want to compare that here? We know that in this case here, for the price, we want to compare not just the price per can, but the price per ounce. That's what we need to compare here. In this case, we're talking about $1.40 for 28 ounces. So if you start comparing then by the ounce, we want to get that down to how much are they paying per ounce for 1 ounce. So to get the per ounce here, we're going to multiply by 1 over 28. So $1.40 divided by 28 or times 0.18 is going to be equal to 0.505. So basically you're paying 5 cents an ounce for this store over here. How does that compare to the other prices? Well, let's look at our cheap price. Our cheapest price was 75 cents in terms of ounces, they all were a 15-ounce can. So 75 cents for 15 ounces. So to compare it by an ounce, to make that 1, we're going to multiply by 1 over 15. So that becomes 0.05. So in reality, if I go to the fourth store, the last store here, and buy the 20-ounce can of beans, right, I'm going to end up paying the same price as the best price there. So it'd be a better price than all the stores, but it actually would just, except for the first one, which would match the first store's price. So buying more in that case does get you a little bit better deal. All right, so in summary, we have here that a little example again of people running kilometers in 20 minutes and then meters in 17 minutes and looking for how you compare those things. And you can compare different speeds, different constant rates by making tables and seeing how they compare and ultimately getting down to a place where you have a similar number here. In this case, you're looking for how much in 1 minute, and once you get that 1 minute established, you can then see are they greater than, less than, or equal. So the point with all that is that when you're finding ratios tells us how much of a quantity A per unit, so how much of a quantity A per 1 unit of quantity B is an effective way to compare rates in different situations. So we see that a lot as we look at things like miles per hour, dollars per pound, and things like that as you go through math. Alright, so we're going to pause there, give you some chances to work on your homework. We'll come back and take a look at that again in just a second. Alright, homework time for lesson 5. May and Priya were on scooters. May traveled 15 meters in 6 seconds. Priya traveled 22 meters in 10 seconds. Who was moving faster? So because I want to find out who's moving faster, I want to put these in terms of the same meters per second. So we're looking for meters for 1 second. So when you compare May is doing 15 meters in 6 seconds. And we want to find out how much she does in 1 second is the idea. So we would do 15 times 1/6, which is 15 over 6. Now, what is that? I'm not quite sure yet, but let's leave it there for just a moment. Let's take a look then at Priya. And Priya is going 22 meters in 10 seconds. So we want to put that in terms of 1 second. So Priya ends up with 22 over 10 because we're multiplying by 1/10. Well, 22 over 10 can be, worked on a calculator to end up being 2.2 meters per second. This one, I know that 6 goes into 15 two times, and I'm left with 3, right? So I'm left with 3 over 6, and 3 over 6 is the same as a half, so I really have 2.5. As a decimal, that is 2.5 meters in 1 second. So who's actually going faster? We would say that in this case here, May is going faster because she's going 2.5 meters every second, which is more than Priya's 2.2 meters in a second. So first one, we got the how much per one, and then we compared the two. Number 2. Here are the prices for cans of juice that are the same brand and the same size at different stores. Which one has the best deal? So which one's the cheapest? So we can do 4 cans for $2.48, 5 for $3, or 59 cents per can. So this has us doing here, in terms of our dollars and our cans, we have $2.48 for 4 cans. Remember what we want to do? We want to find out how much it's going to cost me for 1 can. To go from a 4 to a 1 can, we're multiplying by 1 over 4. So we'll multiply this by 1 over 4, and that goes into there 62 times. So we end up with 0.62 cents for 1 can. Over here, of course, we have 59 cents for 1 can. So we already have that one done, right? So far this is a better deal. But how about this one? Here we have $3 for 5 cans. We're going to make that into a 1, so multiplying by 1 over 5, and 5 goes into there, 0.60, so 60 cents a can. So we have 62 cents, 60 cents, and 59 cents. So the best deal is Store Z, 59 cents a can. You save a whole penny. Alright, number 3. Cost of homes can be very different in different parts of the United States, which is why I live where I live. Alright, a 450 square foot apartment in New York City costs $540,000. What is the price per square foot? So we're talking about the price per square foot. Right now, the price is $540,000 for 450. We want to find out how much that costs for 1 foot. So to figure that out, we multiply by 1 over 450. So we'll multiply this by 1 over 450. And again, I'd use a calculator on this. So 540,000 times 1 over 450, or divided by 450, is $1,200. So in New York City, the price per square foot is $1,200 for every 1 foot of space. So you have a foot space like this, that little 1 square foot of the floor costs you $1,200. That's exciting news right there. A 2,100 square foot home in Cheyenne, Wyoming costs $110 per square foot. That's a big difference there, isn't it? How much does the home cost? Okay, so for that, we're going to take the square footage of the house, and we're going to multiply it by how much it costs per foot. So 2,100 times 110 gives you $231,000 is how much a home costs there. So you're getting a 2,100 square foot house compared to the 450 square foot apartment. So it's a much bigger area for your house and a much more affordable price there. So it's almost half the price there, or less than half the price. But it's just where you live. So there you go, Wyoming folks, congratulations. It's cheaper to live where you are than it is in New York City, and the traffic's probably better too. Alright, there are 33.8 fluid ounces in a liter. There are 128 fluid ounces in a gallon. Great information. How about how many liters are in a gallon? And our choices are A, 2, B is 3, C is 4, and D is 5. There's on my next page, so I'm not going to flip it over. So what we're talking about here is we have 33.8 liters, ounces are in 1 liter. And then we know we have 128 ounces in a gallon. Okay, so we want to think back to what we remember about liters, right? Liters and gallons are a little different. Okay, we know that when we poured that blue liquid into our liter things, we could put a gallon into 4 and had extra space. So basically, it was about 4 of those. Was basically what it came down to. So we had about 4 times the amount. What's how it works. So 33 ounces, right, in a liter, 128. Cool. All right. So this, to go from 33 to 128, I think that this says like 33 times. If I'm looking here, is that going to be 2, 3, 4, 5? Right? Like how many of these fit over here? If I went with 2, that's going to be about 66, and that's not even close. If I went with 3, I'm about 99. Again, I can go a little further. If I go 4, I end up with 132. That's pretty close to 128. So about how many liters are in a gallon? We would say about 4. And remember that we did that when we had the blue liquid, and they had the 4 bottles. These are not really good bottles. And they filled up 1, 2, 3, and then they filled up like 2/3 of the other one, right? That was about what we did in that little activity, little video we showed with the kids pouring the water. All right, is your estimate larger or smaller than the number of liters in a gallon? Well, our estimate here is about, we would say our estimate is about 132. And that's going to be greater than 128 because we were just estimating there. It's not perfect, not accurate, so it's a little bit too big, but that's okay. So let's take a look at number 5. Diego is 165 centimeters tall. Andre is 1.7 meters tall. Who is taller? So we have 165 centimeters compared to 1.7 meters. Well, what does 1.7 meters mean? We know that inside of a meter are 100 centimeters. So this actually becomes 170 centimeters. So I can compare 165 centimeters to 170 centimeters, and we would say that Andre is actually taller. And our last one, name an object that can be about the same length as each measurement. This is for you. Think about something that could be about 4 inches, 6 feet, 1 meter, 5 yards, 6 centimeters, 2 millimeters, and 3 kilometers. These are all distances. So you think of something on your own, write it down there, and show your teacher how smart you are today. Have a great one, and we'll see you next time.